Okay, new standard. Now everybody's going to learn something new. Okay, this was not covered in Algebra 1. If you're wondering what the point of it is, it's mainly just to prepare kids in trig so they've seen it before. If you're not taking trig, well, that's too bad. You still are going to be accountable to know what you're doing. Now, this just shows you how something works. You have a binomial. There's two terms to the second power. This is how you square a binomial. I'm going to make a second parentheses and just write the same thing. So I'm going to distribute FOIL then. I'll be taking x times x times 4, and then 4 times x and 4 times 4. So that's x to the second, that's 4x, that's 4x. So that's going to make 8x, and then that's 16. So that's my x to the second plus 8x plus 16. Okay, now I have x minus 3 to the second power. So I get rid of that, and I multiply by the same binomial. So I take x times x. There is a shortcut way to do this, but the problem is nobody remembers how to do it. Then negative 3 times x, negative 3 times negative 3. Granted, they want you to teach the short way, but it's hard to remember, so just go with the FOIL. Okay, these then combine to make negative 6x, not 0. They're both negative. They don't cancel. So it's x squared minus 6x plus 9. Okay, what you're doing now on this assignment is this is called a perfect square trinomial. Perfect square trinomial, because you got the trinomial by multiplying two identical binomials. Okay, perfect square is something you can get by multiplying one factor by itself. Well, essentially that's what I have here. It's the same concept as 25 is 5 times 5. Well, this here is x minus 3 times x minus 3. What we're doing today is taking this, getting back to here, which doesn't seem that hard, but it says complete the square and then factor it. You see there's a c here. You got to find what c that is to make a perfect square trinomial. And there's a formula to it. You're going to put an implied 1 right there. That's a, that's b. You got to find c. And what you're going to do to bring in your own c is take b divided by 2 and then take it to the second power. So b is negative 6 divided by 2 to the second power. That's negative 3 to the second power. What's a negative 3 times itself? Negative 3 times negative 3. It's not negative 9. Those of you who just punch negative 3 exponent 2 into the calculator, no. That's always positive, 9. So you can replace your c now with 9. Now here's how you factor. It's actually very easy. You don't have to worry about GCFs. 1 times 9 is 9. It's positive, so it could negative, negative. And we're adding to try to come to negative 6. 1 and 9, obviously not. 2 is a decimal. How about 3 and 3? Well, I think that's negative 6. Okay? Now, here's the beautiful thing about b divided by 2 to the second. It will always be the number times itself. Okay, so that'll be a perfect square up there, and if I use that formula b over 2 to the second, it's always a number times itself. Okay, so the a is 1. You can now ditch your 1 and just write that as x minus 3 times x minus 3. Now, because these are identical factors, you write it as x minus 3 to the second power, and that's what I want to see. Okay, moving right along to the next one. A, B, you have to find your own c. You're going to go b over 2 to the second. So b is 20 divided by 2 to the second. Well, 20 divided by 2 is 10 to the second. 10 to the second is 100. So c is going to be 100. Just put 100, put your c. Now go factor that perfect square trinomial. So a times c, that's going to give you positive 100. And add to positive 20. Now think about it. What number times itself is 100? It'd be 10 times 10. Now that adds up to negative 20. We have positive 20, but I can fix that if I just change the signs. Okay, out of here, and I write x plus 10, x plus 10, and that becomes x plus 10 to the second power. By the way, if you get this and you just want to go write that, that's fine. That's cool. But just know why you're doing it. Okay, applied 1a, that's b. Today we'll always have an implied 1. Tomorrow on the next one you won't. So we take b divided by 2 squared. So b is 12. That'd be 6. Basically what you're doing is taking half that number, 6, and taking it times itself. That's essentially what you're doing. So 36. Okay, now factor that trinomial. Rewrite it in factored form. It is a perfect, anytime you use this, you end up with a perfect square trinomial. Positive there, and it's always going to be positive, okay? And I'm pretty sure 36 would be 6 times 6. And we're adding to try to get to positive 12. Well, that's negative 12, so I just changed the signs. Okay, a is 1, so that would be x plus 6 times x plus 6. But we know that can be written because they're identical binomials as x plus a binomial squared. Okay, next one, b over 2 squared. Okay, so you get negative 16 divided by 2 to the second. That's negative 8. But if you take negative 8 times itself, that's 64. So C is 64. And now factor the trinomial. It's positive 64. Now 64 is a perfect square. What number times itself can equal? Remember, you're trying to add it to negative 16. 8 and 8. How about that? Okay, so negative, negative. Now these would add up to negative 16, so we don't want to change the signs. We can write that as x minus 8 quantity squared. Okay, go over to, I already did this one, I'm not doing it again. Okay, now this one can give you some hard times if you don't pay attention. Okay, so implied 1, a, b, and we got to determine the c. B over 2 squared. Be 2 divided by 2 to the second. That's 1 to the second. 1 to the second is not 2. Okay? 1 to the second is 1. 1 times itself. Okay? A times c, it's 1. It's positive. Well, 1's a perfect square. It's 1 times 1. And we're trying to add it to positive 2. Now, negative 1 plus negative 1 is negative 2. Like that. Okay, so a is 1, so I go x plus 1 times x plus 1. So it's x plus 1 quantity squared. Okay, pause this video and then go work the problems. Okay, 1 through 8. Shouldn't take you very long. Okay, then go to the next part. Now, we already discussed this. This is standard form. Okay, if you remember that, remember to find the vertex opposite of b, 2a, negative 3. Standard form, I set that equal to 0, negative 3. Now, funny thing happens. If I find my y's on the calculator, I plug in these numbers. I got 5. Then I'm pretty sure that's going to be 5 because it is a parabola. I find the vertex, we're going to replace the 2's with 3's. Okay, 4. Now let's take a look at this one. Negative, instead of x plus 3, we're going to go negative 2 plus 3 to the second, and then plus 4. That's 5. Negative 3 plus 3, 4. On vertex form, it's always the opposite there, and then you end up right there. Because HK. Opposite of 8. Yeah. So 4. And you're just going to end up at 5. Now look at these two tables. What do you notice? Oh, how about the fact that they're exactly the same? These are the same equation, okay? They're in different forms. Now converting, I'm going to be honest with you in this little paragraph. Converting standard form to vertex form is an important advanced algebra skill, supposedly. I don't use it a lot in here. We don't use it a lot in Algebra 2, but I don't want to set people up to fail going into trig, okay? If you're not taking trig, that's too bad, okay? You still are going to have to do it. Now, this is standard form. You need to wind up in vertex form. There's a procedure to it. You write y equals out 3 times, not once, not twice, not 3 times. You're going to put the implied 1 right there. Tomorrow you won't have a 1. There'll be another number hogging the 1 spot, which is another set of problems. Okay, first thing what you do is you make a parentheses and you write 1x to the second minus 8x, and you kick the minus 25 out of here. That is not going to be the c that you're going to use. And then you're going to add. So this is a, this is b, and your job is to come up with the c. Now we're going to do what we just did. We're going to take b divided by 2 to the second. So b is negative 8 divided by 2 to the second. That's negative 4 to the second. Negative 4 times itself is 16. Now, here's the thing. You just brought a 16 into this equation from out of nowhere. So you need to go to the other side and keep your equation balanced and put a plus 16 after the y. That keeps it balanced. Okay, you with me so far? But I want the y by itself. So then I'm going to minus 16, and then I'm going to minus 16 after the negative 25. So that's how that works. Now set up your t-table. 1 times 16, 16. It's always going to be positive, so we'll start off with negatives. And remember, this always results in the same factor. Well, what times itself? 16. It'd be 4 and 4. Now you're trying to add to negative 8. And that does the job. Okay, my a is 1. We can lose that. And it'd be x minus 4, x minus 4. I'm rewriting this. And then I go negative 25 minus 16, which is negative 41. That's how you should be putting it in. Now, last step's really simple. You just write that as a binomial squared. X minus 4 to the second minus 41. And now you're in vertex form. Okay, next one. If you set this up, it gives you some direction. So put the implied 1 there. And your first order of business is to make a parentheses with the 1x squared, the 18x, but I put plus 2 out here. Because you need to come up with a new c, so it's a perfect square trinomial. So we use b over 2 to the second. So b is 18 divided by 2 to the second. So that's 9 to the second. That's 81. So I just brought an 81 from out of nowhere on this side of the equation, so to balance it, I add it to this side. But now I don't want that with the y, so then I subtract 81 after the plus 2. Or you can do it under the plus 2 as well. Why don't you just do it under? Okay. Okay, so we need to factor that expression. I know that's negative 79, but I got to factor this trinomial. It's 81 positive. And we're trying to add negative, negative. We're trying to add to positive 18. 81 is a perfect square. It's 9 times 9. If you look at the board, the square root of 81 is 9, meaning it's 9 times 9. But that adds up to negative 18. You better make them both positive then. Okay, so your a is a 1, so you can get him out of there and rewrite that as x plus 9 times x plus 9. 2 minus 81 is negative 79. That becomes x plus 9 to the second minus 79. Well, I guess one thing that most people forget is they just bring that number in, that 81. Remember, you have to balance it by, if you're adding it here, you got to add it to the y. But then you're going to get rid of it by subtracting it. Okay, next one. Boot the plus 6 out. So you're going to have 1x to the second minus 4x plus, and then I'm looking for a new number. That's a, that's b, and I got to come up with the c myself. So it's b divided by 2 to the second. So that's going to be negative 4 divided by 2 to the second. That'd be negative 2 to the second. Negative 2 times itself is 4. So I'm going to bring a 4 in, so I got a plus 4 to y, but then quickly minus 4, and then just put it under your 6. It's like you're balancing the equation twice. First by adding 4 to each, and then getting the 4 away from the y by subtracting it. You know that's 2, but let's rewrite that trinomial in factored form. Okay, so we're going to take 1 times 4 is 4, positive. And we're trying to add that to get to negative 4. It's got to be 2 times 2. Okay, and that adds to negative 4. So the a is a 1, implied 1, so I can just rewrite that as x minus 2 times x minus 2 plus 2. Okay, now that can be a binomial to the second power. Boom goes the dynamite. It's really not a hard thing, it just seems like kind of silly. So put the 1 in front. Kick that minus 2 out, and you have 1x to the second plus 16x. Okay, so that's my a, that's my b, and I got to come up with my c. Remember, that's b divided by 2 to the second power. So b is 16 divided by 2 to the second, so that's 8 to the second, and that's 64. Remember, you got to balance the equation. Now, I put plus 64 on this side, so I go over to this side and put a plus 64, but I don't want that with the y, so now I'm going to click minus 64 from the negative 2. I know that's negative 66, but I'm going to write that in, I need to do the factoring on that. 64 positive, okay? And we're adding that to try to get to positive 16. Well, I think that's 8 times 8. That adds to negative 16, so just flip the signs. Now you're at positive. Okay, so rewrite that. Again, if it's an implied 1, you can just go x plus 8 times x plus 8. And you got to figure that out. It's negative 66. So it's x plus 8, quantity squared, minus 66. Booyah. Okay, I'm going to go with 2 more. Put the implied 1 there, and we have minus 6 out here, and we got 1x second plus 20x, a, b, and I need to come up with a c that makes a perfect square trinomial. This process is called completing the square. So b divided by 2 to the second, so that's 20 divided by 2 to the second. 20 divided by 2 is 10 to the second, and that's 100. Now again, you just brought in a plus 100. You got to keep the equation balanced by adding 100 to the other side, but then quickly subtracting 100 because I don't want it with the y. It's like I plus 100, and then quick minus 100, but then you minus 100 from the constant at the end. So a times c, it's 100 positive. You're trying to add it to 20 positive. What number times itself is 100? That would be 10. And I'll say positive, so start with them as negative, but you got to get positive 20 out of it. So positive. Okay, so A is a 1. You can forget him now. If it's not a 1, you got other issues, but you're not going to see that today. I was nice. So x plus 10, x plus 10. Simplify there, it's minus 106. Negative 6 minus 100. Then I write that as x plus 10 quantity squared minus 106. Okay, last one. Put that implied 1 there. Kick out your plus 11. A, B. 1x second minus 6x. A, B, and you better be coming up with a C that makes a perfect square trinomial. How do you do that? By taking B divided by 2 to the second power. Now, B is negative 6 divided by 2 to the second power. So it's negative 3 to the second. Negative 3 to the second is 9. Now, you just brought in a plus 9, so you're going to plus 9 there. But then quickly say, gee, I don't want a y plus 9, so I minus 9 from 11. 1 times 9 is 9. And you're trying to add to get negative 6. 3 times 3 will work just fine. Negative. That's negative 6, man. Okay. So your A is a 1, so you rewrite it as x minus 3. X minus 3. 11 minus 9 is 2. So you get x minus 3 to the second plus 2. Bingo.